Imagine walking in a field full of flowers or into a supermarket. You are greeted with an aroma of different scented flowers or fruits. The different scents are known as esters. Esters occur naturally in many plants, and they are directly responsible for the odors of the fruits you eat daily and the strong scented flowers. Many processed foods have synthetic esters, which are often added as flavorings to processed foods and as scents to cosmetics and perfumes. In this video, you will be learning about what esters are, how to name esters, how to draw esters, the properties of different esters, and the different types of reactions. So, what are esters? The word ester was coined in 1848 by German chemist Leopold Gmelin, probably as a contraction of a German acidic ether. Esters are used to make pesticide, aspirin, plastic soap, artificial flavors, create scents, and make solvents for paint. In chemistry, an ester is a chemical compound derived from an acid and an alcohol. The functional group is commonly encountered in organic chemistry, characterized by a carboxyl group in which the hydrogen atom is substituted by an alkyl group, COOR. When read from left to right, the RCO comes from the carboxyl acid, and the OR comes from the alcohol. So how do you name esters? Just like all compounds, the first step is to identify the functional group, and in this case, locate the ester, the COO functional group. 2. Identify the alkyl chain making up the carboxyl acid. Note that the carbon double bonded to the oxygen atom is the first carbon of the carboxylic acid chain. Name the alkanoic acid. Change the end of the name from oic acid to O8. 3. Identify the alkyl group that had replaced the H of the carboxylic group, COOH, to RCOOR. Name this alkyl group. Assemble the name by placing the name of the alkyl group before the modified name of the alkanoic acid. Remember to leave a space between the two words. This is how you name ester. To name the following compound, I first drew the line diagram structure as it would be much easier to understand. I located the ester and identified the carboxylic acid and alcohol in the ester. The carboxylic acid was a 3-carbon chain, which means that the alkanoic acid was propanoic acid. Then I changed the oic acid suffix to O8. The parent chain was named propanoate. Now it was time to identify the alkyl group, which replaced the hydrogen from the carboxylate group derived from the alcohol. The alcohol was a 2-carbon chain, and it was called ethanol, and then changed its name to an alkyl name, which was ethyl. The alkyl was then placed before the modified carboxylic acid, which was then named ethyl propanoate. So how do you draw esters? The first step is to identify the name of the alkyl group and the name of the alkanoic from which the ester is derived from. Split the ester name in 2 groups. Draw the structure of the alkanoic acid from which the ester is derived from. Remember that the carbon atom that is double bonded to the oxygen atom is the first carbon atom in the chain. This is where the number 1 carbon is because the COO bond is given the highest priority. Remove the hydrogen atom that is bonded to the oxygen atom of the carboxylate functional group. Use the name of the alkyl group, the first word of the ester's name, to determine how many atoms are in the alkyl group chain of atoms. Starting from the oxygen atom in the carboxylate group, which has lost its hydrogen atom, draw in the chain of carbon atoms required using a dash to represent a covalent bond between the carbon atoms. This is how to create a diagram for an ester.
How to draw an ester.
The first thing I did was name the alkyl and the alkanoic from which the ester derived from. I identified the alkanoic and how there are 4 carbons in the chain, due to the prefix being bute. Then I drew the structure and removed the hydrogen atom bonded to the oxygen, as that is where the alkyl group would be placed. I used the alkyl name to identify that there is only 1 carbon in the alkyl chain, as the prefix was meth. After I removed the OH bond in the alcohol and replaced the hydrogen from the carboxyl group mentioned earlier, this is how the final structure would look like as I combined the carboxylic and the alcohol group by removing the H2O. The properties of esters are: the functional group of an ester is similar to the carboxyl group of an acid. However, it lacks the OH group, hydroxyl. as it is replaced by the OR group. With the loss of the polar hydroxyl group, esters are less polar, and therefore less soluble in water and have a low melting and boiling point. It is the low molecular mass esters have to allow us to detect the scent, because they are gases at room temperature. Carboxylic acids react as other acids do. The neutralization reaction of a carboxylic acid occurs when a carboxylic acid reacts with an alcohol, forming an ester and water. In this reaction, the alcohol is acting like organic base due to the hydroxyl group, and the ester form may be considered an organic salt. This is a condensation reaction, which is also known as esterification. An acid catalyst such as sulfuric acid and heat are generally required for the reaction to occur. It is interesting to understand that by tracking the oxygen atom using isotopes, it has been found that acid contributes to the hydroxyl group to form water molecule. In this reaction, the general definition for esterification is a condensation reaction in which a carboxylic acid and an alcohol combine to produce an ester and water. When esters are treated with an organic acid or a base, the reversal esterification occurs. This is when the ester is split into its acid and alcohol components. The reaction is hydrolysis. When esters are heated with a strong base like sodium hydroxide, a hydrolysis reaction occurs. The sodium salt of the acid that result are what we call soap. The soap making process is called saponification. As we learned previously, when a carboxylic acid reacts with an alcohol in an esterification reaction, a water molecule is eliminated and a single ester molecule is formed. The two reactant molecules are linked together in a single ester molecule chain. The condensation reaction can be repeated multiple times to form not just one ester molecule, but many esters joined in a long chain. This is called a polyester. This is accomplished using dicarboxylic acid, which is the acid with a carboxyl group at each end of the molecule, and a diol, which is an alcohol with a hydroxyl group at each end. Ester linkages can then be formed end to end between alternating acid molecules and alcohol molecules. Polyesters are esters which can be formed repeatedly and joined together in long chains. The large molecules of repeating units are called polymers. A monomer is the repeating subunits. They have a relatively low molar mass. Here is an example in which two repeating monomers are produced. An acid and an alcohol are reacted multiple times, and because of the hydroxyl groups on either ends of the compound, a reaction can take place. The product is two repeating monomers, and when the reactants reacted, they produced a polymer. Thank you for listening to my video and hope you learned something about esters.